from populations. Now, we don't know whether they've been actually effectively taken from the same population, okay? But what we do know is that at this stage, if we just assume that they've been drawn from populations, the first sample would have been taken from a population that has a particular proportion associated with it, and the second sample would have been taken from a population that has a proportion, yeah? Okay, from a population that has a proportion. This is like where we have a sample mean taken from a population that has a specific mean value, if that makes sense. So let's assume that pi 1 is the true proportion, is the proportion, okay, with respect to where sample 1 was drawn from, and let's assume that pi 2, okay, was the proportion, okay, with respect to where sample 2 has been drawn from, okay. So what we'd like to do is we'd like to do a hypothesis test that tests whether the proportion with respect to the first population is different to the proportion with respect to the second population, based off the sample evidence that we have here with respect to two sample proportions. And the test statistic that we're going to actually use for this, okay, so maybe I should write this down. This is a test, okay, of the difference between two population proportions. Now, the test statistic looks actually quite complicated looking, but it's actually straightforward enough, okay? And it looks something like this. It's actually a z-statistic, okay? It's z, okay, is equal to proportion 1 minus proportion 2. That's the proportion 1 with respect to sample 1 minus proportion 2 with respect to sample 2, minus what we're hypothesizing the population proportion to be for where sample 1 was taken from, minus the hypothesized value of the proportion 2, okay, where the sample 2 was taken from, divided by, okay, what's known as the standard error, okay. It's divided by this value which is known as p bar, okay, which we're going to figure out how to calculate that now in a moment, times 1 minus p bar, okay, and that's to be multiplied by 1 over n1, the first sample size, plus 1 over n2, the second sample size. And actually, it's the square root. It's the square root of this particular quantity here. Okay? Now, we already know what P1 is and what P2 is. P1 is 0.9, P2 is 0.8. Okay? We know what N1 is the size of the first sample, which is 120, and N2 is the size of the second sample, which is 150. So the only values that are missing is pi 1 and pi 2, and this p bar. But actually, we define p bar, okay? P bar, okay, is defined to be, okay, where p bar, okay, is equal to x1 plus x2 divided by n1 plus n2, okay? So where x1 is the number allowed to keep, it's the proportion of successes, okay? So x1 is the successes, okay, the successes in sample 1, okay? In sample 1, and x2 is the number of success in sample 2, okay? So we need to calculate this particular thing. N1 is the first sample size and N2 is the second sample size. So we need to actually do this calculation before we get to start the actual hypothesis test. So we know what P1 and P2 is. Let's just write that down again. So we have P1 is equal to 0.9. We calculate that up here. And we have P2 is equal to 0.8. We calculate that here earlier. So P bar, which is equal to x1 plus x2. Well, x1 is the number of successes in sample 1, so it's 108. Plus x2, which is the number of successes in sample 2, which is 120, relative to the total pool sample size, which is the first sample size, which is 120, plus the second sample size, which is 150. Okay, so when we do that here, okay, so what we got, we have an open bracket 108 plus 120, okay, which needs to be divided by 120 plus 150. Okay, and that gives us a value of 0.84 to 2 decimal places. So that's 0.84. So actually, effectively, we nearly have everything that has to go into our Z statistic. We have P1, we have P2, and now we've got P bar, and we have N1, and we have N2. So the question is, what is this pi 1 and pi 2? So when we start our hypothesis, we'll be able to figure this out. Okay, so the question that's being really asked here, okay, in this particular instance, okay, the question that's being asked is perform a hypothesis test at the 5% level of significance to determine whether the proportion of traders down that were permitted to retain their tracker mortgages differs. Is it different between the Cork Bank and the Cavan Bank? Okay, so you know that when it comes to the hypothesis test itself, the hypothesis test, that we've got 4 steps. Okay, so when it comes to our hypothesis test itself, we're going to have 4 steps. So our hypothesis test, step 1 is to define the hypothesis, and we know that our hypothesis has a null position and it has an alternative position. And it's always a statement about the population parameters. It's always a statement about the populations that the samples were drawn from. Okay. Now, we want to figure out whether there's a difference between the proportion associated with population 1 for the Cork Bank compared to population 2. So what we have is, we have population 1 has to be compared to population 2. Okay. The proportion